What is going on, guys? Welcome to the first video of learning Java. Become a Java engineer. Learn Java from absolute beginner to all the way to advanced. Our aim is here at Cryowood to show you guys the best ways to learn Java and become a Java programmer. So Java is one of the best languages in programming. Java is general purpose object-oriented programming, but every programmer loves. So if you guys learn Java, there is immense opportunities for you guys to get a job. This video is designed for you guys. If you don't know anything about the programming, that's fine. We're going to show you the computer architecture. We're going to show you all the parts of the computer, and we're going to show you all the memory, how the RAM, how RAM works, how the media card inside the computer works, how the CPU works, and how the motherboard works. What is the assembly language? What is the binary? And our aim is to show you guys, if you guys don't know anything about the computer, show you guys every bits and tricks. I'm gonna familiarize with you all the way from the classes all the way to functions. We're gonna go on through the loops. We're gonna go on the conditional loops. We're gonna go on the while loop. We're gonna go all the way to object-oriented classes, functions, how you guys gonna create your custom functions, how you guys gonna create your custom classes, what is the class constructor, what is class destructor, what is inheritance, what is polymorphism inside the Java, all the way to the advanced level. So one day you guys gonna feel that you guys can write a big Java programs without any hassle or with ease. So the more you guys practice, the more you guys gonna recall this memory, and the more you guys has to construct the coding inside your brain. To become a Java programmer, you guys needs to think like a programmer. So just like to become a bodybuilder, you guys need to think like a bodybuilder. What the bodybuilders they do, how they do the reps, how they handle the barbells, how they handle the weights, how they do their routine, how they say, for example, they want to build their shoulder, how they build the chest, how they build the muscles, how they build the lower part of the body, how they build the upper parts of the body. So that's exactly same true with the programming, but the programming is an art. Keep in mind, we as a programmer, we are dealing with something like artist. So don't think that you're learning just to go for become a part of the system of a company, or you guys go and do some sort of jobs to earn money. That's fine, by all means. Initially everyone needs a job, but as you guys become advanced, I would suggest you guys go and create awesome program inside Java. You guys can create web applications inside Java. Initially, Java was created for web applications called applet. You guys can go and create games. You guys can do the Android programming with Java. You guys can do enterprise programming with Java. So you guys can even create a search engine with Java. I have seen a lot of search engines, data mining, artificial intelligence. You guys can do a lot of things with Java. So if you know Java very well, knowing a Java is absolutely essential for any successful programmers to come in the field of programming and to earn a very big money. So if you guys go to Silicon Valley, or if you guys go all the tech companies, they prefer you guys know Java. So they prefer you guys know everything, get a very good hold of Java syntax, Java architecture, object-oriented part of Java, because Java is object-oriented language. You guys needs to know the functions very well. You guys need to know the classes very well. So you guys need to know how to inherit classes from the parent class to the child class, or from super classes. We're going to show you guys the super classes, and we're going to show you guys the polymorphism. And most importantly, if you guys know the compiler, and if you guys know the interpreter, because Java is both interpreted language and compiled language. And Java is portable. It means you guys can do in any computer, whether it's Windows or Mac, or say for example Linux, and there's a lot of versions of Linux. You guys can run your Java program with no problem. So my job here is to show you guys the best ways and for every best tricks to become a Java engineer. All right, so everything in programming has to make sense for you guys. If you want to be a successful programmer, everything has to make sense. If something doesn't make sense to you, it means you guys, if you don't understand one part of say for example programming, it's the next part is not going to make sense to you. So every part has to, every step of the way, I try my best to show you guys the best way to become a Java engineers, because we are running C++ and we are nearly finished our C++. If you guys interested, go and watch our C++. And I'm also running the Python, and my Python, we are reaching towards the object-oriented Python. So if you guys interested in Python, go and watch our another videos in learning Python. All right, so without further ado, I'll go and start Java. This is the first video in Java, so I congratulate you guys for starting Java with us. So we're going to go ahead and we're going to see the first slide. So the first one is, what is Java? Java is currently one of the most programming language, as I said to you guys earlier. So Java is very, very popular, and it's been popular since 1990 when the Java first began with the Green project, and Gosling is the father of the Java, and I'm going to show you guys in the next video. And Java was initially created for the microwaves and ovens in 1990. That was the main purpose of the Sun microsystem, because the Sun microsystem used to they are the creators of the Java. They are the company which was taken by Oracle, and Oracle is the owner of the Java at the moment, and they are the ones who release all the Java versions. So longest story short, Java is a general purpose language. It means you guys, as I said to you, you can use it anywhere. By general purpose, we means we can use it in web programming, we can use it in Android programming, we can use it on small devices, you can use it on big devices, you can use it on any devices you like. That's what we mean by general purpose programming. And object-oriented programming, the object means that the thing. In plain English, objects means thing. Oriented means is revolves around things. It revolves around classes. So for the things, for us to tell the computer that this is a thing, we need to define something. We as a human, we know that the objects around us, say for example apple, our banana, our peach, our mountain. Say for example, you can see around yourself a road or street, anything, any objects such as pets, or we can see ourselves as objects too, because we have a property, and objects have a property, and objects has a attributes. So anything that revolves around this one, we call this object-oriented programming. Means that we do our source code, we write our source code, and the language means that language is a Java language. So we have a spoken language such as English, German, Japanese, Chinese. We have a computer language such as we call it Java. We have a C++, C, we have a Python, Fortran, JavaScript, we have a HTML. We have a lot of languages. So why we need to learn Java? Because Java is a general purpose object-oriented language. And the one thing that makes Java unique and distinct from other programming languages, because it's platform independent, because it doesn't need any platform. Just like assembly language, when you guys go in assembly language, you guys need the platform. Say for example, if you guys building for Intel, say if the Intel is 16-bit and you're writing your assembly language for Intel 16-bit, then the next day you guys going to see the Intel's say for example a few months the Intel going to release another 32-bit. So that whatever you write, all this effort and everything's you done put it inside the place for 16-bit is not going to work on 32-bit, because the architecture is different. So for example, the 32-bit, and Intel is not gonna just release one computer for 32 bits, it releases all sorts of computer. Say for example, Samsung is gonna create another one, then Asus is gonna create another one, then Toshiba is gonna create another laptop. So all of them, the architecture is different. But if you're gonna write on assembly language, it means that you guys need to write on everything, on every platform. So but Java, you guys don't need that. You guys, there is no such thing as you guys need a platform, because for all these operating systems. So that is a platform independent, because we don't need any platform or architecture to run our program, and it's very fast. One thing every programmer in the programming community is familiar and admit is Java is very fast and intended for programmers for write once, run anywhere. You as if you're working in a company, you're gonna only write one code. Say for example, if your code is gonna be opening the video or running a video, you're only gonna write once, and you're gonna run on any platform, whether it's gonna be Apple or it's gonna be Linux or it's gonna be say Mac. That's what we call this one Vora, W-O-R-A, or Vora. So when we say Vora, it means we're gonna write once, run anywhere. Unlike as I said previously, I like the assembly language, which if you guys write once, then it doesn't mean that you're gonna run anywhere. You're gonna run on that specific platform. Say for example, if it's written for Intel 16-bit, you're gonna have to run on 16-bit. If you run on 32-bit, then you guys can't run it on 64-bit, because the architecture of the 64-bit of the Intel is going to be totally different to the architecture of the 16-bit. And that's a difference. And as the computers growing very fast, like according to Moore's law, because all these transistors getting cheaper and cheaper, so building a program such as assembly language is very, very difficult nowadays, because you guys can't just come and write for every platform. Or say for example, with all these new technologies coming, and all these transistors getting cheaper and cheaper and cheaper, and the computers becoming faster. Say a long time ago, 1 gigabyte was unimaginable in 1990, say 1995 or 1986. You could not imagine 1 gigabyte. I started my programming in 1997, and I could not imagine 1 gigabyte, because for that 1 gigabyte to run, you guys needed supercomputers at that time. At say for example 80 or 1970, you guys needed a supercomputer to go and compute for you 1 gigabyte, because the earlier computer was only 4-bit. So, and the 4-bit turns into 8-bit, 8-bit turns to 16-bit, 16-bit turns into the 32-bit, and they also multiply that again, 32, 64-bit, and the next one you guys can imagine is going to be 128 bits going to come. But we don't need that fast computer, because at the moment we have a 64-bit, and that's quite enough for a single user, or for a company to run a lot of programs at once. Okay, so, and with the Java, as I said, you guys don't need that, because you guys are free. You guys just write your program once and you can run it anywhere. So for example, if you guys making a game, then you guys write your game or whatever program you guys like, program of your choice. You guys just write once and you guys can run it. Then you guys don't have to worry if the platform is Windows, if the platforms are Linux. By all means, if the program platforms Mac OS, Apple OS, whatever, then you guys don't have to worry that what platforms you guys gonna encounter. So that's one thing good about Java, and that's one thing that every programmers agree, and every programmers around the world loves about Java, and that's the reason Java is popular. According to GitHub, in 2019, Java was one of the most popular language, with estimated 9 million developers around the world. Say for example, if you put 9 million developers in one country, it's going to be a country of their own. Say for example, in New Zealand, the population is going to be around 4 to 5 million. Say you can make 4 to 5 million people, say twice as the population of the New Zealand. And if you are look around the world, there are a lot of countries with the 4 to 5 million population, or even some countries they have less than 4 to 5 million population. So 9 million developers around the world using Java. So if you name one country called Java, it's going to have its own population, is going to have its own president, prime minister, is going to have its own ministers and cabinet, whatever, and you can name that country Java. So Java by itself have a 9 million developers around the world. So that's what is it's a very, very popular programming language. We're going to see that Java has 5 principles. And that's what the base of the Java. When the Java created, they had a 5 principle in mind and 5 goals. That the first one is Java has to be simple, and Java has to be object oriented and familiar. So with the simple, it has to be very, very simple for everyone to use. It has to be object oriented because all the programmers can solve the very complex programs or can solve a very, very challenging task with the object oriented very easy, because it has a lot of tools for every problem. Say for example, if you guys want to tell the computer that this is my pet and my pet is dog, and dog is called for example Rex, for example. So how you going to create with procedural programming? It's impossible for you guys to create with something called procedural. With the procedural, you guys procedural, we mean for loop or while loop, we can do the loops and we can do the numbers, we can do plus minus, we can do all the arithmetics, we can do everything. But how could you going to tell the computer that this is a object and the object's name is belongs to the class animal, and the animal belongs to the class, another one, class dog, and the dogs has a say attributes and has for example, it has a name, it barks, it shouts, whatever, and it has properties, it has legs, things like that. We as a human, we understand that because our brain is engineered, our brain was designed to understand the objects around us because we can see, and that, but just seeing, that's input. We can input all the objects inside our brain and we can map it. So how you going to tell the computer, because computer doesn't have the eyes and computer doesn't have the say common sense, and computer is not self-aware. Computer can't process without us as a human. We have to write source code and we have to tell the specifically computer that this is a object and this object is animal and this animal is a dog. So we need the object oriented, and object oriented provides that tool. So object oriented programming provide the tool to solve all the big complex programs into very, very simple. So we can just write a class animal, and that class animals gonna have build a constructor, we're gonna tell the, we're gonna build the functions, we're gonna build the attributes, we can build after that, we tell the, then the computer knows that this is objects, this object is a dog, and this objects, the dog name is a dog and the dog name is a Rex. So with the objects oriented programming, it's very a lot easier. So we even can create a child of that class. Say for example, we can create a super class and we can create a child class. Say for example, that dogs has a puppies, and that dogs has a say another puppies, and dogs has a partner. So we can create all sorts of a map with just object oriented. So object oriented is a core of Java principle. And Java, when it was designed at the Green project in Sun Microsystems, Java was built to be object oriented. So it was designed to be object oriented from the beginning, and it was designed to be a very, very familiar. And second goal that the Green project inside the Java had in mind was Java has to be robust and secure. So it has to be very, very fast and has to be robust. As soon as you start this one, it has to go like a jet, like a boof. It goes like that, and has to be very, very secure. So anyone can build their programs. It has to be bug free and has to be very secure. So you can build an enterprise application with ease. You can build a very strong and you can build an enterprise application with a large scale and enterprise application and very complex applications with ease. So the next goal that Green project is one of their goals is has to be the programming language that they're building has to be the architecture neutral and portable. As I said to you guys, architecture neutral, it means that you guys can just build a program for one specific architecture. Say for example, you guys can just build for Windows. If you build for Windows, what about Mac OS? What about Linux? Because Linux has a lot of kernels and has a lot of flavors. So what about other platforms? So in order for programs to be successful, you guys just can't create for one architecture, a specific architecture, otherwise you're going to lose the market share. So you guys can't just create for one. Nowadays if you notice that every company has an app for Android, and the same company has an app in Apple iOS phone. So for example, and that companies try to make app for the two platforms at once. For example, you guys just can't create one app just for one platform. Say for example, Facebook has an app for Android, and Facebook has an app for Apple iOS. So for example, you guys, but that's a different story, because for Android you guys need to know Java and Kotlin, and for Apple you guys need to know Scala, but that's another programming language. Say for example, but inside the computer, because computers, most of the computer is written inside the C++, so it's very suitable for Java to come and build a program, because Windows are written in C++, Linux are built inside the C++, and Apple iOS was written into Objective-C, and Objective-C is very quite similar to the C++, and for Java to come and build a program for 3 of these platforms, it means it's going to be very easy, because Java itself was written inside the C++. So Java has something called write once and run anywhere, and it was designed to be architecture neutral, and it was designed to be portable, and we're going to show you guys what we mean by to be portable. Okay, so the fourth one is it is fast and execute with higher performance. The fourth thing that Green Project has it in mind for a program, because they are designing a program and they wanted the program to be fast and execute with high performance. And as I said to you guys, this number 4, this program has to be fast, execute with high performance, and that one we mean by interpreted, because Java is both interpreted and compiled. And for interpreted, we means that when you guys execute your program, it's going to be it is executes very fast, instead of it goes all the way to the machine language, creates all these zeros and ones. So Java is interpreted, it means that it's very fast, it executes fast, and is also compiled. That's the reason Java is very fast. As I said to you guys, Java is architecture neutral, and it is completely portable. And if you run the Java source code, our Java code in every other platform, is for example, if you have identical Java code, it's going to run on different platform with ease. It's regardless of the hardware compatibility or operating system, such as I said to you guys, it has to be Windows. So if it's Windows, or if it's Linux, or is it Mac OS. Keep in mind the Java source code, it first compiled into the binary byte code. It's called byte code. We are using Java compiler. Then this byte code runs on JVM. It's called Java Virtual Machine. And what is this Java Virtual Machine? Is we call it JVM, and that one's we're gonna discuss in our upcoming videos. In our future videos, it's just a software based on interpreter, and that's why Java is both considered as to be interpreted language, and Java as compiled language. To be successful Java engineers, you guys need to know interpreter, and you guys need to know compiler. And Java is also multi-threaded. So multi-threading in Java features that allow concurrent execution of 2 or more parts of a program for maximum utilization. Each part of the program that you're running is called thread. In simple words, a thread is a lightweight process within a process. So there is a process, say for example, if you guys, a simple explanation, if you guys has downloading a video, say for example, if you guys download one video, the thread starts for one video. This is example. And you downloading another video, another thread starts. Then you downloading the third video, the thread starts, and the downloading 4 video at the same time. All of these are independent of each other. All of these as a process within a process. So you create a download process here, you create another download process here, you create another download process here, you create another download process here. By this one we mean multi-threading, and that's the simplest, easiest everyday, because you guys download every day, the example I can give you. And that's exactly the multi-threading works in Java, because once you guys create a process, and you guys create another tiny lightweight process inside the process, and this is called multi-threading. And multi-threading and concurrent, when you guys hear this one, concurrent is another word for multi-threading. And what we mean by dynamic, the main idea of the dynamic is because we're going to break down a very complex programming into very smaller sub-problems, and then we're going to save them into memory, that we don't have to recalculate them each time we use them. So that's the definition of the dynamic, because Java in or decomposition. We call the dynamic or decomposition is the same word. Sometimes it's you have a big problem and a company comes and give you a very big massive problem that I have such and such thousands and millions of staff here, and this staff uses comes at this time, shops at this time, goes at this time, so there are a lot of problems. So what you guys do here with, because Java is built on it's a dynamic and it has a object oriented, so you guys creating this big problem which is millions and billions of people into a small sub problem. So you guys going to create two sub problems here, and from these two problems you guys can create, from the left problem side of the problem you guys going to create another two problem, and on the right side you guys going to create another. So you, and in other words, you guys making like a tree, and this is called dynamic and this is called decomposition. Because programming, we mean by decomposition, we're creating a very big problem into small chunks of small sub problems. So in programming, the dynamic programming, as I said to you guys, we optimize recursive all our programs. So the main idea, as I say, I'm going to explain to you guys, is to break down complex problem into smaller sub problems and then save them into memory, so that we don't have to recalculate them each time we use them. We just do it once. So we divide our big problem into smaller problem, and in the future videos we're going to go on the dynamic programming again, and I'm going to show you guys when we start the Java what is dynamic programming, so you guys have a very good grip. I'm going to bring a big problem for you guys, say for example such as Fibonacci sequence, and we're going to divide that Fibonacci sequence into the very small sub problems, and then we're going to divide that sub problems into another sub problems, and finally when we have a smaller chunks of the problems, then we're going to divide that one. So I welcome you guys again to the learning Java. So you guys having very good videos coming in the future videos. You guys gonna be the Java engineer and Java master in no time. All right guys, that's it for this video. If you guys have any question or comment, leave in the comment box. Otherwise I'll see you guys in the next video, and bye.